In this half of the lesson, we're going to review the principles of adding and subtracting fractions. We're going to look at fractions with common denominators, which is the easiest option. And then by the end of the lesson, you should be able to add and subtract fractions without common denominators. It is essential that you know how to complete this portion and show your work without relying on any calculator shortcuts. So make sure you're understanding, and if you're not, please contact me. Let's jump into some new material. And I'm going to make my little video here disappear because I'm going to need some extra space to write a few notes for you as we go. So, adding and subtracting fractions with like denominators. That's our first thing. So when we add and subtract fractions with like denominators, we're simply looking at pieces that are all the same size. So one of the rules for adding and subtracting is, first of all, we only add or subtract the top or the numerators. Okay, excuse my writing, that's absolutely horrendous. I'll see if I can actually make that a little bit more legible. So we're only going to add and subtract the numerators as long as the denominators are constant, okay? Okay, we only add and subtract the numerator. I just am having a hard time writing here. And the second thing that we have to know is we must have a common denominator. All right, so add and subtract the numerator, you have to have a common denominator. So here the denominators are the same. So the bottom number is both 5. So we're adding fifths. If we're adding fifths, we're going to get fifths out. 2 plus 1 leaves me with 3. So the answer for this particular question is as simple as 3/5. Those are the really common ones from back when we were in elementary school. 3 plus 5 leaves me with 8. I was adding tenths, so 8/10. We need to reduce this, and we can divide both by 2, and that leaves us with 4/5. Okay, 4/5. We look at the next one, 3/8 minus 1/8. So again, we're just going to deal with the numerators. The bottom will stay the same, the denominator will stay constant. 3 minus 1 leaves me with 2, which reduces to 1/4. Just simply dividing by 2 and dividing by 2. 6 and 4 leaves me with 10/7. So 10/7. You'll notice here we have an improper fraction, so we need to turn it into a mixed number. So in this particular case, there's 1 7 in 10. 10 take away 7 leaves me with 3 left over. So 1 3/7. So that's the easiest type of question you can have. Denominators are already the same. We just add or subtract the top and then do our reducing once we're done, or turn it into a mixed fraction once we're done. Fraction rule number 3. You had 2 rules in the last lesson. Rule number 3 is when adding or subtracting, you always need a common denominator, no exceptions. You must have the bottom number, the fractions be the same. So let's look at some questions where they're not the same, and we'll figure out how we deal with them. So in this question, we're taking 7/8 and we're adding 3/4 to it. We need to make all the pieces the same size. So if you look at these, well, if we take 4 and double it, we would get 8. So we don't need to change the first fraction. We're going to just change the second fraction. So let's take our second fraction. We're going to double it. Okay, multiply the top and the bottom by 2. And this will give us 7/8 plus 6/8. Now we can combine these together. 7 plus 6 leaves me with 13/8. We have an improper fraction. So I'll do that over. I'm just going to use the side here for some scrap paper. So 13 divided by 8 goes in once. 8. I'll subtract that. Subtract here, and we'll get 5. So that's 1 and 5/8 for an answer. Okay. So again, we're always taking our improper fraction and we're turning it back into a mixed number. Now, when you're doing your quizzes on the computer, if you don't give me the mixed number and you give me the improper fraction, it's going to end up being marked wrong. I don't have every variation of the question in there, but because you always give your mixed number, if you give me 13/8, that technically is not a correct final answer. So keep that in mind as you do your quiz. 5/8 plus 3/16. Again, 8 times 2 is 16, so let's just change one fraction. So this will give us 10/16 plus 3/16 gives us 13/16. There's nothing more we can do with that. That is as reduced as it can be. So we would just leave it. 3/4 minus 1/3. So we're going to make our denominators the same. Now in this case, the only way to make a connection between 3 and 4 is to go 3 times 4. So we're going to take the 4 and we're going to multiply it by 3. And whatever we do to the bottom, we're going to do the top. We're going to take our 1/3, we're going to change both fractions. And we're going to multiply it by 4, both the numerator and the denominator. If we multiply both the top and the bottom, it keeps it balanced to get our new equation. So 3 times 3 leaves me with 9. 4 times 3 is 12, minus 1 times 4 is 4 over 12. 9 minus 4 is 5/12. And that's as simplified as we can get. Okay, same thing for the next one. 5 and 2. Well, the only connection between 5 and 2 is to do 5 times 2. So we'll do the 5 times 2, 3 times 2, and then 1/2. Well, we'll take the 2 and we'll multiply it by 5. And this will give us our new fraction. So 3 times 2 leaves me with 6/10 minus 5/10 equals 1/10. And that's our final answer. So that should be a really quick review of some things you would have learned probably at the grade 4 or 5 level, somewheres in there. Now, when we get to mixed numbers, there's a few techniques that sometimes teachers don't show. And there's some good strategies in here. So I'm going to show you a few strategies that you can use in order to simplify the math. If you are somebody that is going to take these in order to solve them and turn them completely into improper fractions, you are doing too much work. So I want you to follow along with how I'm doing it. I'm going to give you the shortest path to get to the right answer. So we have 2 3/8 plus 1 1/4. The first thing we need to do is we need to make our case size the same. In other words, we need to make a common denominator. So if we take 1 1/4 and we take those quarters and we divide them each into 2 pieces, that would leave us with 8s. So basically, we're just going to take our denominator and multiply it by 2 to get an 8, which means we also have to do it to our numerator. Now, we don't have to multiply the wholes by anything because it doesn't matter how many are in the case if you've got the whole case. Okay, we've got one whole set. So this is going to turn our equation into 2 3/8 plus 1 2/8. Now I've got 2 whole cases and part plus 1 whole case and a part. How many whole cases are there altogether? Well, we know we have 3 whole cases even if we ignore the fraction part. So we are going to add our whole numbers separate and then we're going to add our fraction part. So this is going to be equal to 3 and then we're going to have a fraction part. So we have 3/8 here and 2/8 here. So that's going to be 3 and the 8s that we have because that's our common denominator. 3 plus 2 is 5. So for mixed numbers, we're going to combine the fraction and the whole number separate. Now I have shown, sometimes I've shown another way to write that. Sometimes I'll have students that have trouble keeping track of that. I'll say, well, think of it this way, 2 3/8 plus 1 2/8. This way you can see it. 2 plus 1 gives me 3. 3/8 plus 2/8 is 5/8. That's just another way of kind of looking at the question. It's exactly the same math, just written a little bit different. Let's do the next one. 3 7/8 plus 2 3/16. Well, we need to make our denominator common, so we're going to multiply by 2. So this will leave us with 3 14/16 plus 2 3/16. So let's do like we did before. We're going to do the whole number and the fraction separately. So 3 plus 2 leaves me with 5. The fraction part, 14 plus 3, leaves us with 17/16. Now we can't leave it like this, okay? This is an issue. We need to convert that. Okay, so 17/16 is equal to 1 1/16. So that means if I had 5 to start with, and this piece here is equal to 1 1/16, that must mean this is equal to 6 1/16. Okay, so we're breaking it apart into 2 pieces. Then if you get an improper fraction, you switch the improper fraction and then just combine the whole number parts. Hopefully that works for you. We'll do it a couple more times. 8 3/4 plus 2 1/2. So let's take our half, multiply it by 2. Again, we always just multiply the fraction piece. So 8 3/4 plus 2 2/4 is equal to 8 plus 2 is 10 and 5/4. 5/4 is the same as 1 1/4. 5 take away 4 leaves me with 1. So there's 4 in this set of 1, plus there was 1 left over, so 1 1/4. So this must be equal to 10 plus 1 1/4 leaves me with 11 1/4. A lot less chance for mistakes doing it this way than if you turn everything into improper fractions, because the numbers get really messy when we do that. We'll see that when we multiply and divide. And then the next one, 8 3/5 plus 1 3/4. Common denominator in this case would be 5 times 4 is 20. So we're going to multiply by 4 and change both of them. And we'll multiply this by 5. So our new fraction is 8. 3 times 4 is 12. 20ths plus 1 15/20 equals 9. 8 plus 1. 12 and 15 is 27 over 20. 27 over 20 is equal to, well, we know there's 1 20 and 27, so 1. 27 take away 20 leaves you with 7 left over. So we have 1 7 over 20. That means this must be equal to 10. So 9 plus this 1 and 7/20. Now, if you're stuck with any portion of this, please make sure you stop by and see me or ask some questions. I don't mind showing you, and sometimes it's easier to show in person when somebody can ask questions and I can kind of see where the mistakes are happening. So that's as complicated as it gets for adding mixed number fractions. Find the common denominator. If you get an improper fraction in the middle, you have to combine the improper fraction with the whole number person, turning everything into a mixed number that doesn't have improper fractions. So our next question we're going to look at subtracting mixed number fractions, and we're going to use exactly the same process. So the first thing we're going to do is find our common denominator. So for 4 3/4 minus 2 1/4, we already have a common denominator. So we're going to subtract. I like to subtract the fraction. Then we're going to subtract our whole number. I will post a list of kind of step-by-step procedures for those of you that like step-by-step procedures. I haven't really written them out step-by-step here, but I will give that to you. So subtracting the fraction part, 3 minus 1 leaves me with 2 quarters. Don't worry, we'll reduce later. Subtract the whole numbers, 4, take away 2, leaves me with 2. So 2 and 2 quarters. The fraction part can be reduced because we can divide both of them by 2, which leaves me with 2 and a half. Okay, nice and straightforward, nice and easy for us. In the next example, we have 6 take away 3 and a half. Now this is one that most times I get mistakes on if I ask this question in class. A lot of people will tell me, well, that must be 3 and a half. But if we did 6 take away 3, we'd be left with 3. If we're taking away 3 and a half, we're taking away a little bit more than 3, so we have to have a number that's smaller than 3 left. So I'm going to show you how to write this out the fraction way, and I think that will solve the issue for you. So we're going to rewrite this 6. Would you agree that 6 is equal to 5 and 2 halves? I think that's logical. 2 over 2 is the same as 1, so 6 equals 5, and 2 over 2 is 1. So if we combine those together, that gives me 6. So we're going to write this question out just a little bit differently. We're going to have 5 and 2 over 2 minus 3 and 1 over 2. Leaves me with, subtract the fraction portion, 2 halves minus 1 half leaves me with 1 half left over. 5 minus 3 leaves me with 2. So we're left with 2 and a half. That makes sense. 6 take away 3. I'm taking away a little bit more than 3, so we should have a little bit less than 3 left over. 2 and a half is a little less than 3 left over. So just using logic to check our answer. Let's jump down here. 3 and 3/16 minus 1 and 3/8. Find our common denominator first. Oh, just before I do that one, let's jump back up to this 6 minus 3 and a half. When I do this, the fraction that I choose here, I look at what the denominator is in what I'm subtracting, and I match them right from the beginning. So instead of a half, if I had an 1/8, I would automatically go to an 8 on the bottom. I think I have another example of this in perhaps the next slide, where we have a different number on the bottom. So, but that's how I choose that, is I just pick a common denominator based on what I'm subtracting from. It doesn't matter what we choose, as long as the numerator and the denominator are the same to give us a fraction of 1. So let's go back to here. 3 and 3/16 minus 1 and 3/8. So we're going to multiply top and the bottom by 2. 3 and 3/16 minus, subtract 1, and 3 times 2 is 6/16. Now in this question, so we've been subtracting the fraction part first, and the reason for subtracting the fraction part first is for questions like this. 3/16 minus 6/16. We can't subtract that because we would get a negative number. The second fraction, just the fraction part, is larger. So we're going to do what I call borrowing. This is one of the trickier things when it comes to subtracting. So we're going to borrow. So 3 and 3/16. Let's write that another way. 3 and 3/16 is equal to 2 and how many 16ths? Okay. So what I'm going to do is I'm borrowing a whole, and I'm taking one whole case and I'm putting it in with the part cans. That way I can subtract from it. I'm breaking it up. So there's 16 cans in a case. I had 3 part cans left. So the top here is going to be 16 plus 3, which leaves me with 2 and 19/16. Okay, so 3 and 3/16 is the same as 2 and 19/16. And this makes a great in-between step for us. Now I'm just going to kind of section that off so we can plug in numbers here. So 2 and 19/16 minus 1 and 6/16. We can do this question now. 19 minus 6 leaves us with, what did I do for my math here? Oh, I'm good. I'm good. 13. I'm your brain fart moment. 2 minus 1 leaves me with 1. So 1 and 13/16 is our final answer for this question. You could have completely turned everything into an improper fraction to subtract, and that would be perfectly acceptable. This way is actually a little bit of a shortcut. It does take a little getting used to, so it does take some practice. Let's look at the next one. We have 6 3/8 minus 1/2. Make our common denominator first. Multiply the top and the bottom by the same thing. So numerator times 4, denominator times 4. So we have 6 3/8 minus 4 over 8. So 4/8. 3 take away 4. We subtract the fraction part first. We can't do 3 take away 4, so we have to rewrite 3 and 6 3/8. So 6 3/8 is equal to 5 and how many 8s? Well, we took one set of 8 away to get 5, so we're going to add it back into the top. So the top number, numerator, is going to be 3 plus 8, which leaves me with 5 and 11/8. Okay, so we're going to plug that in. That'll be our new fraction that we'll use. So 6 3/8 is the same as 5 and 11/8 minus 4/8. There's no whole number to subtract, so it's just going to stay as 5. 11 minus 4 leaves me with 7/8. Okay? Subtracting is always a little bit trickier, so I did throw a couple of extra questions in just to give you a little extra practice. Let's do these ones. 5 1/8 minus 1/4. So to get the common denominator, we take our quarter and we're going to multiply the numerator and denominator by 2, because 4 times 2 is 8. 5 1/8 minus 2/8. I can't do it, so I have to borrow. I have to turn this into another type of fraction. So 5 1/8 is the same as 4. Still have an 8 on the bottom. I'm going to subtract 1 from the whole number, and I'm adding 8 into the numerator. So 4 and 9/8 would be the same. You'll always get an improper fraction in the middle here when you borrow. Minus 2/8 leaves me with 4 and 7/8. All right, next one. 2 1/2 minus 3/4. Common denominator first. Multiply the numerator and denominator by 2. Notice we're not multiplying the whole number, just the fraction portion. So 2, oh, sorry, not 2, 12. 12 and 2/4 minus 2 3/4. We have to borrow because the numerator is smaller than on the first fraction than it is on the second. So I'm going to subtract 1 from my 12, and I'm going to add that 1 back in over here as quarters on the fraction side. So we have 11 6/4 minus 2 3/4. 11, take away 2, leaves me with 7 3/4. All right, so pretty straightforward. And then the very last one of those ones that I say a lot of people make mistakes on this on their test. So I don't have a fraction, and I need a fraction to subtract a fraction. So we're going to take our 7 and we're going to split it up. We're going to say 7 is the same as 6 and 8/8. I'm picking 8s because I've got 8s there. Take away 2 3/8. Leaves me with 6 minus 2 is 4. 8 minus 3 is 5/8 for our answer. All right. And last but not least, we'll throw in 2 tape measure questions. For these ones, I want you to write and evaluate a subtraction problem that allows you to determine the length of each line segment. So you'll notice for this particular ruler, It is in eighths, not sixteenths. So you have to kind of pay attention to that. We have 4.5 minus, here we have 2 and 1/4, 1/2, 3/4. Make the denominator common. 4 and 2/4 minus 2 and 3/4. And we're going to borrow 3. Subtract 1 here, add in 4. 3 and 6/4 minus 2 and 3/4 leaves me with a length that is 1 3/4 inches long. Now you could actually figure that out pretty easy here. If we take, there's 4/4 in an inch, I group them, there's a set of 4/4, and then I've got 1, 2, 3 left over. So we could just use it, do a visual inspection to find the answer to that question. Let's look at the next one. In this case, we have 6 and 1/8, and then here I have 3.5. So 6 and 1/8 minus 3.5. Make a common denominator, so 6 and 1/8 minus 3 and 4/8 is a half. Okay, so then we have to borrow. So we're going to subtract 1 from the 6 and add in the 8 cans that are in a case. So 5 and 9/8 minus 3 and 4/8 leaves us with 2 and 5/8 of an inch. Okay, and we could figure that out quite easily just by looking at grouping. So we're starting at a half mark. If I go to the next half mark, there's 1 inch, 2 inches, and then in terms of here, in terms of our groupings, we're ending on the smallest section, so we have to count the smallest groups. So we're going to count 8s. We have 1, 2, 3, 4, 5 8s. Very last question, I'm just going to write the solutions in for you. If you're doing this question, you should get 2 inches for your line length, and for this one, you should get 3 and 3/8. And if you're checking your measurements as you go, just if you get stuck, this should be an easy one because it's 2.5. And here you have 4.5. And then here we have 3/8. And on this side of the line, we have 3 and 3/4. Okay, so that just gives you your final answers for you to be able to check and just do it as practice. So in summary, for adding and subtracting fractions, I did include the rules. I just saved them to the end. Common denominators are mandatory. This should always be your first step. If they don't match, make them match. It's required. Mixed number fractions can stay. Don't change them to improper. You're slowing down the process, generally speaking. To add or subtract, you add or subtract only the numerators, borrowing when necessary during subtraction. Then you add and subtract the number of remaining wholes, combine the whole and the fraction to give your final answer, and simplify. Always simplify your answers. They should always be in lowest terms, written as mixed number fractions if there's an improper component.